Yeah, welcome also from my side. Nice to have you here. I hope you had already fun at Notes 2023. And yeah, I'm thankful that I can attend and provide you with some Java-based GraphQL stuff. I'm Gerrit, who doesn't know me. I'm developer in the Spring Data Neo4j team at Neo4j. Also involved in Neo4j OGM, all graph mapping stuff, Java related. So you might ask, why this talk? It's Java and Java Java and GraphQL, and typically we sometimes hear those sentences. You can either have a JavaScript TypeScript application and provide a GraphQL API, or if you want to provide REST APIs, you should choose Java. It sounds somehow more mutually exclusive than a decision of transport technology to choose for various languages. And since there is also GraphQL possible in Java, I wanted to clarify that it's not only possible within Java, it's possible within Spring application. It's possible also then including Spring Data Neo4j. And if you already have a Spring Data Neo4j application, for example, it's easy to build upon this. So you have now seen half of the slides already, because we will go through a live demo in a few minutes. And there you can see it by example, how you can build GraphQL APIs on top of your already existing Java application or Spring Java application. Also, you can just start from scratch, but it should also give you some kind of impression how to create such applications or such APIs when you already have an existing application. So just in a few slides, what is Spring for GraphQL? It's in Spring terms a pretty young project. So you can see it in the timeline. The first major version came out just in the middle of last year. We are still in this 1.x version phase. The library is created by VMware. And since a few months, it's not only something we have seen and adapted to this, but also we provided test cases for the core test suite to support Spring Data Neo4j. So if a test would fail for Spring Data Neo4j in this case, we can adapt Spring Data Neo4j, and you can profit already from the existing functionality, or we can extend the functionality. So we have a, let's say, canary that really fails fast right in the middle of the core project of Spring GraphQL. So that's basically it. That's everything you need to know. That's theory. It makes fun to create GraphQL APIs with this. Really trust me. And for this, I want to start with a demo. So I don't know about the audience. Hopefully, yeah, perfect. Hopefully, you can give me some feedback. If you want to know something, you can ask questions. Maybe I can see them and react to them on the fly. If not, I will try my best to answer them after the session. This talk primarily is focused on people who are already a little bit familiar with Spring Data Neo4j. But I will try to bring up the important informations during the demo, etc. The database or the data set we are working on with today are PC games. So oops, just a second. Of course, it does not work. I created an instance a free instance to import some games from Steam. So it's more or less a random collection of games with several meta informations that we can query and see in a bit. So just for example, if we want to query some data and see how our data structure looks like. So we have a game, notes with some description, a Metacritic score, so we know which games are at least community-wise good or bad, rated. We have a price in cents. Don't ask me why. And some various other meta informations. So, but as we know, with a graph database, it's much nicer to have connected data. So we can see, for example, Quake was published by Bethesda. We have some developers like the well-known ID Software, and some genres or categories the game takes place in. That's the graph for you, so you have something in mind when we are querying the data in a bit, how it looks like. And if you have looked at the details, please, I know that the Quake is a little bit older, but somehow it just came to Steam on this date. So these are the Steam release dates. Yeah. So if you want to play along or afterwards with a similar application, maybe the same application, if you get the data from somewhere, I can really just advise you to go to the Spring initializer. So this is start.spring.io, where you can create a bootstrap application based on Spring Boot. As a classic Java developer, I would choose Maven. In Java, we take the latest stable version of Spring Boot and add some dependencies. First of all, of course, Spring Data Neo4j. Then we use we define Spring GraphQL, and since Spring for GraphQL is not bound to web technology or HTTP transport, we need to also define the transport library. This could be also a WebSocket or RSocket, if you know about the reactive socket library. I prepared this already in my local project because I mixed in the game import first. So maybe just without the source data, I can then provide this project later on GitHub. So it's if you are familiar with Spring Boot applications, this is a pretty classic application starter. I just added something to import the games on application start if no games exist. And I put the configuration for Neo4j, Spring Data Neo4j, into an external configuration file to have a cleaner setup here. Also, I already created our entities that we want to work with today. So in the main focus, as I said, we have a Game Explorer application, or we will have a Game Explorer application. There is our main entity, the game. And now, if you're not familiar with Spring Data Neo4j, we characterize our entities that should represent nodes in Neo4j with the node annotation. It's important that they have a unique identifier. But also, as we have seen this in the graph in the browser already, we can define relationships to other entities or nodes. In the case of Neo4j, then entities. I tried to separate between entities in our Java world and nodes in Neo4j world and in the database. Two data entities that represent also nodes like developers, the publishers, categories, or the genres. That's basically it. So a developer, publisher, category, genre is more or less just a wrapper class right now in my example here. So if you look into a developer, you can see, okay, it's a node, as I already described it, and it has an identifier. And the identifier is a name. So I took the simple approach to say my unique identifier is a name, because names are usually very unique, or not, depending on what data set you're working with. So in my case, or in this example case, it works. But of course, you should always reflect that your IDs are unique. So having set up this domain class around the game, I imported all the games from the JSON file, separated it to nodes, and then the developers, publishers, categories, all, of course, distinct throughout the data set, and then put it into Neo4j. But this is not where we are here for. We want to see GraphQL, yay. So assuming that you have already a Spring Data Neo4j application, you typically have at least one repository defined. In our case, the game repository, and it gives you access to load data, delete data. When I say load, it's also finding data, etc. So you use this repository class for those who are not so familiar with Spring Data Neo4j. You use this repository class to directly load entities from the database. So SDN creates the cipher statements and maps the incoming nodes relationships to the proper entities in the Java world. So in we see this the example, or doing the whole example. And if you have detailed questions, you can see this. This game repository gives us access to our games with its relationships. So, sorry. So when we typically start then to introduce new APIs in our application, like the GraphQL API, we need to define what we want to query for, right? And the GraphQL schema definition that we have here allows us, for example, say, I want to get all games. And so you don't need to see me typing. We want to see all games, and the type of the game has certain properties that we can then look up and query for. That's basically all you need for your first steps to create a GraphQL API, more or less. Because in Spring projects, you have this kind of magic that the projects try to get benefits from each other. So, for example, the Spring for GraphQL project knows about the functionality of Spring data repositories. So if it does not, in this case, if it does not have an explicit defined query method for this game's endpoint, or for this game's query, it looks into the repositories, and then it mostly is by convention that it will look for something that would return something that looks like a game. So these types are loosely coupled, but in some sense they are more coupled under the hood. But we shouldn't care about this right now. So The only hint we need to give to Spring GraphQL is that our game repository that we already using, if this is an existing application, needs to get annotated with GraphQL repository. This does not make it exclusively get used by GraphQL, but it adds this functionality to the game repository. And we can already start this while I'm talking. And the benefit of this GraphQL library in the Spring Boot application is that it also comes out of the box with graphical support. So if you don't know this, GraphQL is a visual browser explorer, or how you want to call it, for GraphQL APIs. And this is what we will have a look on right now. Oh, just give me a second. I need to find the right screen for this. Here it is. Sorry. So also, this is a graphical browser. So it already has loaded my schema definition, for example, for games, where I can then say, I want the name of all games. And this creates under the hood, under the hood, the method chain to call the Spring data repositories, which then creates the cipher statements to get executed against the database. And then the mapping chain comes back. And after mapping the result, the nodes to Java entities, the GraphQL library takes place and serializes the outcoming data to the GraphQL response. Is this in the browser? Yes. I assume, Casper, you are asking for the graphical UI. Yes. So this is the browser. So you get an endpoint for graphical, and then you can see this. So that's cool, right? But we have not tons of data. It's some magic and one use case that works. Maybe there should be more, right? And of course there is more. Otherwise the talk would already be over. So going back to our query definition, we might want to have a search exactly for a specific game title or game name. So just adding this without any further changes to our application, we're not only getting this query, additional query, where we can add the name for game query for. Oops. Because we don't have any time, I just take a break. Maybe we want to just do something more. And now even more automatic functionality takes place, because the Spring data repositories are also supporting the so-called query DSL or query. No, sorry, they are also doing this, but query by example. This means that Spring for GraphQL creates now a query object, a game object that looks like something with the name Quake, a game with the name Quake, and hands this over to Spring Data Neo4j. And Spring Data Neo4j can interpret also this kind of queries, and will create or derive the matching query for this. So we now can also filter, for example, by name. We could put in every property that we know on our Java entity, to query for. And we will get those results. We can also combine them and similar things. So having this in place, it's already, I think, a nice functionality. Of course, I've spoken about graph databases, relationships, etc. Of course, we can also put in, for example, a publisher. Just need to redefine the publisher with the name that we have already seen. And since it's an identifier, we can just put in string. Let me just restart. So after editing the schema, I need to restart the application, but this is very, very fast. And we can then also put in publishers. I want to get the name of publishers. And we get, and you can imagine, you can go as deep as you can define your queries or your entities, your types in the GraphQL schema. But this is not all. Sometimes we come to the point where this pure automatic function does not work with repositories. Then we would need to manually add some fields or some queries to our GraphQL API. For this, I create a new Java class, a controller in this case, because naming is so hard. I just call this controller, put on the stereotype from Spring. So this is a general stereotype to say it's a controller class. And then I can also say I want to introduce a new query mapping. So for example, games, where I return a list of the top games. I don't know. Games, sorry. For this, I need to manually call my repository. So I can then say return repository find more top, then by, then I could insert a condition, but I just skip the condition, so we can just then continue with order by Metacritic score. Should have chosen shorter names. Of course, this does not exist, but those find top methods are built-in methods that we can derive from in Spring Data Neo4j. So I get my find top 10 by method created here, and the Cypher query will get derived from here. I just need to define something. Oh, name top games. I will return game. So as you can see, it's more manual work with this repository right now. You could also imagine that we put external calls to other systems in there at the controller level. This is because we now don't see any automation that combines the world of Spring for GraphQL and Spring Data Neo4j. You could call also other data stores or similar things at this point. But I just wanted to show you that it's easy to just add also functionality that is not baked by this. It's not baked by this magic automatic mechanism. But I get also oops, games. And I want to get the name of the top games. Okay, maybe it's interesting to see that I'm not lying. So I add the Metacritic score. So we see the best rated games that we have. And we have so such a few minutes left here right now. So one thing that I really excited about that is in there is also the support for cursor connections. So we have seen this with games. Sorry, that time is flying. You could, for example, also define a schema that contains the well-known in the GraphQL space, well-known cursor connection specification, where you don't return games directly, but you return additional information about the pagination. You can add then you need to have a fixed sort for this. You can add those metadata also there. But I think Notes 2023 is somehow, I don't know, probably coined by a certain theme around the AI. So I just want to hijack my session, and we can add maybe some more queries that make use of something I really, really, really love to show you. I just call this now magic. Maybe you can already guess when I put in phrase. But it's really, really cool. That's why I haven't showed you my Maven definition in the beginning. So my Maven definition also contains a snapshot of the latest version of Spring AI. We have, so my colleague Michael and me, we have contributed to the Spring AI project that uses vector stores or defines vector stores for certain stores. For example, also now Neo4j. So this makes use of our new vector index search. And it also provides those information to the database. So I stored some games already in the I stored this some games already with this vector embeddings, so we can query for them. So maybe you have more ideas than I do, as an idea for external APIs. This was the initial idea. For you want to ask different APIs to aggregate for your GraphQL endpoint various sources. You could also use this vector store, for example, right? A vector store works on documents. Oops, sorry. We also put in query mapping for this. We have to define that our search phrase and the vector store. Similarity search, we put in the phrase, we just want to get one result. We are pretty confident that we can find something. And the nice thing is that then this abstract document contains the information we need to then also use our repository again, the find by name method, because the index, the identifier here is the name of the game. This works completely also with this derived finder mechanism. And now we have Spring AI or vector index search built in within our application. And I'm too late. Just give me this 1 minute. Because we also started late. So for example, with this magic function that we have now in there, use a phrase that I want to search for some games, because we get to some games, right? Where small people. It's not really a long phrase, but I will see this in a bit. to have a game with small people, so I get Undertale. But I like small people who are building in mountains. I get Dwarf Fortress, right? That's perfect. Yeah, sorry that I took so long. We have plenty of resources in place. If you have any questions, please reach out to us. I thank you for your time. Sorry that I skipped over. I will answer all the questions in the Q&A. Casper, yeah. Sorry. I don't know what happened. There are so many to discover in the space. Maybe you can see this as a lightning session, a 30-minute lightning session on Spring GraphQL. You can create, yeah, as I said, easy your GraphQL APIs in Java. You don't need to switch your technology stack to JavaScript. If you want to, feel free. We also have this at Neo4j, who supports with our GraphQL library, also with object mapping. It's just an alternative that you could explore when you have already an existing application. Or, of course, if you prefer Java more, do this way. Yes. Before I get turned off, I say thank you for your time. If you have any questions, reach out to us at the community side. Specific Spring Data and Neo4 questions, please, on GitHub. If you experience issues, etc. And also, that's what I missed here. You can reach me on several social networks with Master. Yeah, right. Have a nice conference. See you. Bye.